Hi class, today we will be building series circuits and parallel circuits. So if you remember from your notes, a series circuit is a circuit in which all parts are connected end to end to provide a single path of current. So we're just looking for a single loop here in a series circuit, okay? So basically we're just, kind of connecting everything end to end, and kind of like this, only we're going to actually do that with wires. So end to end. I am going to use a switch. It's always good to use a switch that you know for sure when your electricity is not connected and not flowing. So I already have my wires hooked up to my battery terminal here. Okay, and something I always like to do whenever I'm hooking up my experiments is I always like to start and begin hooking things up from the negative end. If you look here on the battery, you can see it has a plus sign, and here there is a negative. This end obviously is the negative. The plus sign is the sign that has the little nubbin on it, and the other end is the negative end. And I always like to start connecting my things from the negative end, and that's because that's the way that electricity flows. So it always just kind of helps me remember that. So I always like to start. I'm going to start from the negative end, and I'm going to hook my circuit up. So as I said, I do have wires connected to my battery terminal already, have them hooked up together, and I'm just going to connect things end to end here. So this end to this end for my series circuit. All right. Then I'm going to take a wire to connect this end to this end. Okay. And it doesn't matter what color wire we use. For this part, we are using red wire. And then I'm going to connect this end here to my switch. And from my switch back to the plus end of my batteries. Okay, because that's the way electricity flows. Sometimes in videos and stuff you might actually see the arrows coming from the positive end, and that's actually incorrect. So I always want to remember that the electricity flows from the negative end of the batteries around through the loop and back to the positive end. Okay, so we have everything hooked up here. The reason it's not lighting is because our switch is open, which makes our circuit an open circuit. When we close it down, we get light bulbs, nice bright light bulbs. Okay, so basically we can see here that a series circuit just flows in one loop. Now, something we want to look at in this series circuit is what happens if one of the components quits working. So if all of a sudden this light bulb blows out or doesn't work or gets broken, what happens to this light bulb? Yes, it no longer lights. So in order to have a series circuit working, all the components in the series need to be working properly. Just like when the switch is open, then it's not allowing electricity to flow and nothing works. It opens up a circuit, or it opens up a terminal basically here that the electricity cannot flow through, because in a series circuit the electricity is leaving the batteries, it is going into here, up through the light bulb, back down to this wire, through this wire, up to the light bulb, through the light bulb, back down, through this wire, through the switch, and back to the batteries. So it just has one continuous loop. And if one of these light bulbs is taken out, then it doesn't work. Okay? Let's also look and see what happens if we add another light bulb to our system here. Okay? So, we need that one. So I have a few other light bulbs from another little kit that I had, so I'm going to use them for this. And what I'm going to do is I'm going to open my switch, and I'm just going to add in another light bulb to our system here. So I'm just going to disconnect it there, hook it into this side. It'll go up, go through the light bulb, come down, go through this wire, back to this light bulb, through the light bulb. So now we just added another light bulb to our single path. So let's take a look at what happens now. Do you notice what happened? It's actually probably even difficult to see. But you notice they are still lit, but boy, they're a whole lot dimmer. Yeah, when we added a light bulb, it got dimmer. Wonder if it would get dimmer if we added one more. So let's try it. I have another light bulb terminal here. Let's open our switch so that we can. So now we have 4 light bulbs in the loop, okay, in the single circuit loop. We turn it on, and it is almost impossible to see. This one actually is kind of the brightest, but they all just have a tiny little orange dot. Do you see that? I think you can see that there now. Tiny little orange dot. They all have just that tiny little orange dot. It's just a tiny little glow. So we added a 4th light bulb, and these things barely even can light up now. So definitely a problem when you add more and more things to a series circuit. Definitely not getting the kind of result, you know, that you definitely are not getting nice bright lights. So if that's what you're looking for, that's going to be pretty tough with a. So that is a problem. So these are going to be some of the benefits and disadvantages that you'll fill out in the next video that has the bottom part of your student notes. But yeah, so series circuits here seem to have some issues. Well, let's go ahead from here, and we're going to build a parallel circuit, okay? And we're going to see if they have the same issues. So I'm just going to disconnect here. I'm still going to use my switch, and I'm going to disconnect here, okay? And all right, so I'm going to start from my battery, and I'm going to go to this one now. The last time we sort of put them like this so that it would be a nice loop, end to end. This time, we're going to put them like this. Okay, so we are going to go from here to here. So I'm going to hook this one right in here to make my parallel circuit here. Okay. Get that opened up enough. We'll get both of those stuck in there. And oops, they wouldn't cooperate for me, are they? There we go. Okay, so we're going from the battery to here to the next light bulb, and we will go this light bulb to this one. And before I screw that one down, I'm going to slide this other one right on top. So when I put them in there, I'm actually sort of sliding them in so they're like this. Okay. All right. So now I have everything set up in a parallel, okay? And you can kind of even almost see the parallel lines. So I'm just going from the battery to here. It will go through this light bulb, back through the red wire, and back to the positive sign. And also it will go from here, or jump from the red wire to the black wire, through this light bulb, back through the black wire, jump to the red wire, and back to the battery. So let's make sure our light bulbs are tight there. And we have nice bright light bulbs. Okay, so we can see that everything is connected. It is leaving the negative end of the batteries, returning to the positive end of the batteries, and everything seems to be lit. Now, the last time I took a light bulb out and everything quit. So I'm going to try to take this first light bulb out, and then we need to see if it quits on me. So is this light bulb going to stay lit if I take this light bulb out? Gonna give you a second to think about that. Will this light bulb stay lit if I take this light bulb out? Let's check it out and see. It does. It definitely does. So we can see that it is not necessary for all the components to work in order for the light bulbs to stay lit. And the reason that is because the electricity does not need to flow through this light bulb like it did the last time. The last time it came from here, it went into the one terminal, through the light bulb, down, and to the next one. Well, this time, it is going through the light bulb if you take it from the red wire, and then it can go through that light bulb and back through the red wire. But because this red wire is right on top of the black wire, the electricity can just jump from wire to wire and keep on going and make a big loop. So in this case, it can make a small loop through that light bulb, or it can make a big loop through that light bulb. So when we put the light bulbs in, they both work. When we take that one out, that one still works. If we take this one out, yes, that one will still work because it still has a small loop that it can go through. It doesn't need this. Okay, so in a parallel circuit, it's very interesting to see that they do not need to all be working in order for it to continue to work. So when you consider things that are done in series and parallel, one example of a series circuit would be holiday lights. A lot of times if one light bulb is loose or goes out on the holiday lights, the whole string goes out, and that is so irritating from year to year. The other thing that we can consider with parallel and series circuits is your house. And if your house was hooked up in a series situation where one has to go through one to the next one to the next one, then if you turned off your light switch in your kitchen, your refrigerator would quit working. So everything would have to be on all the time in order for everything to run if you wired your house in series. So electricians always wire houses in parallel like this so that you don't need the lights to be on in order for your refrigerator to run. Alright, so if we add more light bulbs to this, we can see they get just slightly dimmer, but not really much. And the neat thing is that, let's open this, that when we add in more light bulbs, grab another wire here. You notice I'm using lots of wires for these parallel. When we add in another light bulb here, okay, now we have 3 light bulbs, and they do get slightly dimmer, but they still maintain a pretty decent brightness. Unlike the series, unlike the series circuit that continued to just get dimmer and dimmer and dimmer and dimmer the whole time. So definitely a better route to go to maintain brightness is a parallel circuit. Okay, so for your homework, I would like to see you answer the discussion questions that go along with a few of the videos and activities. So there are 2 discussion questions throughout the week, and the main homework assignment this week is for you to build me a series circuit and a parallel circuit, okay? So you do not need this extra light bulb here that I was using, you can do your parallel circuit just like this with, these are a little bit loose since I had, okay, so you can build your parallel circuit just like this, and then build your series circuit where everything is hooked end to end, okay? So that is going to be your main homework for the week, is to build those series circuits and parallel circuits. I'd like to see a post-it note somewhere in the picture. When you take a picture of what you've built, please put a post-it note with your name and date on it. Or if you are doing the cutouts of the materials, just make sure you put your name on the paper. So the one is with pictures of real materials or your real materials that you're using. The other assignment is to draw the circuits that you built with symbols. Okay, so you have those two for homework assignments for this week. So that pretty much wraps it up. If you have any questions, be sure to message me, but that is series circuits and parallel circuits.